Hello, everyone. Welcome to today's webinar, Building NLP Applications for Financial Services Using Data-Centric AI. I'm John Marini, Director of Growth here at Snorkel AI, and I'll be your host for today's event. And now it's my pleasure to introduce today's presenter, Arthi Bagal. Arthi is a machine learning engineer here at Snorkel AI, where she enables organizations across banking, healthcare, and government to solve complex ML problems using Snorkel Flow. Before Snorkel AI, Arthi worked closely with Andrew Ng, AI Fund, helping to build and invest in ML companies. Arthi was also a machine learning engineer at Andrew startup Landing AI. She graduated with a master's in computer science from Stanford and with a bachelor's in computer science and computer engineering from NYU with highest honors. And now it's my pleasure to hand the presentation over to Arthi.
Thanks, John. As John mentioned, really excited to be here and talk to you today about building NLP applications for financial services using data-centric AI. If you have any questions, please feel free to add them in the chat and we will get to them at the end. So primarily what I'll be talking about is 3 different case studies today, all of which build on extracting information out of 10Ks. So for those of you that work in the financial sector, you may be aware of 10Ks. Apologies, I live in New York, so background noise. So as you may be aware, 10Ks, these are financial documents. Every public company sort of files these with the SEC every year, and they contain a wealth of information about the company, such as, what is the nature of their business, where are they located, who are the key senior managers, board of directors, what are their financials. So just a lot of information that can be very valuable for a lot of downstream analysis. However, there's no set format for 10Ks. So these occur in a wide variety of formats. And also these are generally very, very large documents. So about 100 to 300 pages. So really challenging for machine learning because of these reasons. So first, as I mentioned, there's a large variability in the types of formats that 10Ks can come in, which is why you need a large amount of data to be able to train a machine learning model to do this. Secondly, for a lot of the use cases, you may need domain knowledge. So one of the use cases that we'll talk about, for example, is extracting interest rate swaps from a 10K, which is a type of financial entity or information. And so to manually label data to extract that information, you need subject matter experts, in this case, FX traders, to take time away from their day jobs to do this. So really not feasible in terms of the amount of data that you need. And then lastly, manual labeling does not allow for rapid iteration. So let's say you come up with a new format for a 10K, or you want to extend the use case to different other amounts that you want to extract, you kind of need to start from scratch. So overall, just a bunch of challenges in terms of applying machine learning to 10Ks. But today we'll talk about how we use Snorkel Flow with our customers to solve primarily 3 different use cases. The first one, as I mentioned, is extracting interest rate swaps from 10Ks. I'll quickly talk about what that is and what we did there. I'll spend most of my time talking about that, and then quickly touch on 2 other case studies. One is extracting KYC or know your customer attributes, such as location, board of directors, assets, etc. And then lastly, risk factor extraction. So extracting sentences or paragraphs relating to different risks that you may care about. Again, as we're going through, please feel free to write the questions in the chat. So let's start with interest rate swap extraction. So for those of you that may not be familiar, why even do this, or why is this important as a use case for a company? So this top 3 US bank that we were working with, they wanted to extract this amount from 10Ks. And the reason is that interest rate swaps are the largest component of the global over-the-counter derivative market. They have a really large notional amount, in this case, 372 trillion. All that to say, this is a very important and large product category for a bank. And the information about this transaction, such as the interest rate swap information, it's customized contract between 2 private parties. And the information about interest rate swaps that a company has undertaken, this information is only filed in 10Ks or 10Qs. And so teams, if they want to influence their selling strategy or get information about, let's say, what interest rate swaps a company that they're talking with has already undertaken, they have to manually go through and review 10Ks to get this information. So in this team, 40 to 45 people, analysts or associates, manually going through these 10Ks, spending 12 to 15 hours per week. Because again, as I mentioned, these are really large documents. So you have to spend 15 to 30 minutes looking for the specific interest rate swap amounts that this company has gone through. And in one summer project, they estimated 263 hours taken by analysts or VPs just for one project. So clearly something that we can automate with machine learning. But again, as I mentioned, the challenges here are that this information can be presented in a variety of ways. So just the interest rate swap amount, it can either occur in this case in a table. So it could say, interest rate contract, here's the notional amount, that's the thing we want to extract. Or it can be broken down by years, it can be broken down by quarters. You also just have a lot of just table variations where in this case we have multiple columns, etc. Or it can occur in a paragraph where it just says the company entered into an interest rate swap with an amount of the thing we want to extract, or it can be split up into multiple amounts, multiple quarters that they've undertaken the interest rate swaps in. So you can just see just a wide variety of information. So you do need to label a decent amount of data for a machine learning model to be able to do well. Now, if you wanted to manually label this data, so manually have traders go through and label, this is an interest rate swap or the thing I want to extract. In this case, we ended up labeling around 70,000 data points. If you wanted to label this internally, again, this is really, really slow to go through and do this. And there's opportunity costs, like you're taking traders' times away from interacting with clients to label data, which people, it's just not a very effective use of the subject matter expert's time. So high opportunity cost there. And again, it's hard to adapt. So let's say a new variation comes up or you want to extend to a different swap amount or a different entity, you're kind of starting from scratch. And then going to labeling vendors is not a great fit here, because in this case, we don't have privacy challenges since these are publicly available documents, but in a lot of financial documents are private and confidential, and so you can't send it out to labeling vendors. And in this particular case, you need domain expertise to label. So just sending out the documents to a labeling vendor would not be a good fit in this case. So the way we approach this problem is through programmatic labeling approach, which is a approach that the Snorkel AI team pioneered over years at the Stanford AI Lab. As some of you may know, Snorkel was a research project at Stanford for over 5 years. And the core idea to come out of that was this idea of programmatic labeling, where instead of labeling each data point one at a time, so going through each amount and saying, is this an interest rate swap amount or not, or manually going through and selecting the interest rate swap, you can specify your rationale for why you think something's an interest rate swap. So in this case, for example, if interest rate swap is in the same row as the number that I care about, or the number that exists, I will want to extract that because that's probably an interest rate swap. So you can write, instead of labels, you can write these labeling functions such as, if interest rate swap is in the same row, label it as an interest rate swap. And this programmatic labeling approach lets you just label a large amount of data all at once instead of one at a time via manual labeling. Some of you may have noticed, these documents come in a wide variety of formats. So these labeling functions that we're writing, they may not be precise. But that's totally fine, because with Snorkel, you can write these labeling functions which can be imprecise or not perfect. And what we can do is when you write many of these functions, we can denoise them and resolve conflicts and get you to one label per training data point. So based on this programmatic labeling approach, I'll give you a couple more examples of labeling functions just to clarify the point before I move on to denoising the labeling functions. But just some other examples of labeling functions. And here I'm showing you screenshots of our GUI-based interface. So you can see that non-technical people can also write these labeling functions. But essentially, just to give some more concrete examples, if I wanted to say this particular amount is a interest rate swap, how do I know that it's an interest rate swapped? Well, if the amount is to the left or the right of the word notional and is to the left or the right of the word interest rate or swaps, then it's an interest rate swap. And this particular function will be able to label a lot of numbers all at once instead of one at a time. Another example, this time in a table, how do I know that all of these numbers in this case are not interest rate swaps? So I can say, if what's in the same line as this number is the word currency or foreign exchange or carrying value or adjustment, basically, how do I define the other class? So you can write the functions for other as well. And so through this process, you'll be able to write these functions that cover a large part of your data. And then Snorkel Flow, our platform, you can write these functions. And then, as I mentioned, we'll denoise these functions that are not perfect into one label per training data point for you. And then we've built an end-to-end platform to support the rest of the workflow around this programmatic labeling approach. So once you label data through this approach, and hopefully you can already see, this is generally 10 to 100 times faster than manually going through each single number and being like, this is an interest rate swap. Write these various functions to label data really, really quickly. We'll denoise it for you behind the hood through our label models. Then in Snorkel Flow, we generally train a model. And the goal here is you can write these functions to label data, and we'll get you to one label per training data point. But we have really powerful machine learning models these days. So when you take this labeled data set that you have and feed it into a machine learning model, the model may be able to generalize beyond these labeling functions that you've written, because there may be other signal in the data that the model will be able to pick up on. So in Snorkel Flow, again, you can train the model in the platform. You can also do this outside the platform. And then after that, we've built in error analysis tools that tell you, how should you be improving upon this model? Generally, people just iterate in a very ad hoc manner, just throw different models, throw different hyperparameters at the problem. But in this case, we actually have concrete error analysis tools to show you, where is your model already doing well beyond the functions? So where should you be iterating on next? Should you be iterating on the model? Should you be iterating on the data? If so, what part of the data? So this whole data-centric AI movement that you may have heard a lot about, where people have heard or people have realized that instead of just iterating on your models, iterating on the data actually gives you pretty large gains in performance. We actually productize it and make it concrete in the platform, such that through our analysis tools, you can very quickly see what is the specific part of your data that your model's not doing well on, and write labeling functions for that part. Again, another thing that is very useful here for with the use of Snorkel Flow is if you just tick the 10K, and in this case we have information in a tabular format. If you just took raw text, it would sort of destroy a lot of the signal that would be important to write these labeling functions or even train a model. But Snorkel Flow also preserves the formatting information here, such that in addition to just the text, well, first we maintain the visual layout, but then also in addition to the text, we tell you where in the document it occurs. So, what is the left, right, top, bottom, what page it's on, what font is it, what's in the same line as this number, all of these things that you can use to write labeling functions, as you saw in the previous example that I gave. So just additional platform benefits as well that work very well specifically for this task as well. So as you've seen here, Snorkel Flow, we're a end-to-end data-centric AI platform based on this core idea of programmatic labeling, but we also have a bunch of key capabilities that are really critical to do well on this structured data extraction task, such as first-class support for PDF semi-structured data, no-code UI, so you can bring in subject matter experts. You can also write custom labeling functions or custom operators in the notebook. Won't read through the whole list, but really a suite of functionality that lets you get a really high performance on this task and other PDF extraction tasks as well in general. So to quickly touch on, what are the results that this customer is able to get on this particular task? Well, first, they're able to label data really, really quickly through this programmatic labeling approach. So writing these functions to label data all at once instead of one at a time, able to label 70,000 labels per minute through this labeling function approach. And then, as I mentioned, you can also, it's not just programmatic labeling, you can also get to a really high quality model in Snorkel Flow through this data-centric approach of iterating on your model and your data. And so through this process, we're able to get an end-to-end application in 6 weeks. We're able to deliver on an even shorter time frame. This is just to account for also time for onboarding, etc. But we're really quick to get to a production level model through this approach. And it's not just that it's fast, but we're also able to get to really high quality models. So in this case, 83F1 for extracting this swap amount. I think also more importantly, it's not just that you have a great model now to begin with, but this model is also more resilient and adaptable, where let's say something changes about the data or something changes about the classes that you care about. Instead of relabeling every single data point, in this case, they just have to go back and modify 30 labeling functions that they've written to label the entire data set. So it's really, really quick and easy to now, if anything changes, you can quickly adapt to changes in the data or the business goals. You can see, you may have seen a couple of screenshots, but essentially we have a very GUI-based interface. So instead of fragmented workflows between subject matter experts and data scientists, we have a unified platform, and we have a lot of workflows built in that I haven't touched on here that really make this collaboration even easier in a single platform. And then lastly, generally with machine learning, when you start new projects, there aren't really economies of scale. You kind of just start from scratch. But here, let's say we wanted to extract a different type of swap amount that may be similar, or just extend this task to other entities you want to extract. Well, in a lot of cases, you can use the labeling functions and just modify them quickly to kickstart the applications for extracting other entities. So there's real economies of scale in terms of kickstarting other machine learning projects that you may care about. And the end result of this, 83F1 is great, but like, how would subject matter experts really use the output of the model? So in this case, this is just one specific way to present the data. We do work with various different ways based on what customers are interested in. In this case now, instead of having to go through an entire 100, 300-page 10K to find the interest rate swap amount, the traders can now just get a table where they can say, here for this given company, here's the swap value that was extracted. Here's a quick surrounding blurb so you can quickly verify if the information is correct. We'll also tell you how confident the model is about this prediction. And then lastly, we'll also give you a link to the particular page that this amount is on and highlight it so that given the context, you can quickly verify it. So various consumption modes that the teams may want, but in this case, now the reviewing of this amount, instead of taking 30 minutes to go through the whole 10K, it may take just a minute or so. You may just want to look at the amounts that the model is not as confident about, quickly review, and now you have about like 5 to 10 times faster review of these 10Ks, and people can spend more time on their actual day jobs or client conversations instead of manual review. So as I mentioned, in this case, the team's reviewing 5,000 to 6,000 filings per year instead of 15 to 30 minutes. With Snorkel, they're able to bring it down to 3 minutes, and it just shifts the time to tasks that actually require their subject matter expertise. So that's it for the interest rate swap extraction. I can see some questions in chat popping in. We'll address them at the end, but please feel free to keep adding more questions. I'll touch on two other task types or case studies for extracting information from 10Ks, and then we'll get to the questions. So very quickly, KYC Attribute Extraction. KYC stands for Know Your Customers. So in this, another top 3 US bank that we work with, they have 300 to 500 analysts manually going through 10Ks to extract various attributes such as, where's this company located or headquartered? What is their nature of business? Who's on the board? What is the total assets of the company? Things like that. And to do that, they're spending 30 to 90 minutes manually reviewing a 10K. And in this case, they're looking at 10,000 plus reports every year. So the application that they're building with Snorkel Flow is given a 10K, which is this large unstructured data, comes in a wide variety of formats. They want to have this output as a structured sheet, essentially, that tells them for a given company, what is the nature of business, who are the key senior managers, total assets, 15 to 20 other attributes, such that now the time is just cut down and we can automate a lot of this work here. And again, in this task, we're able to do really well. It's not just that it's really, really fast, but because you're able to label data really quickly with Snorkel Flow and label a large amount of data with these labeling functions, you do tend to get very highly performant models as well. And in this case, then through this entire machine learning approach, we're able to save 10K person hours per year, which is a large amount of saving. And then I think also importantly, a lot of the applications that you build are very adaptable or resilient because you can very quickly modify these labeling functions to adapt to changes in your data or business goals. Lastly, just to quickly touch on the risk factor extraction task. So far we've seen extractions of particular entities, maybe amounts, location, etc. But with Snorkel Flow, you can also build applications to extract, let's say, sentences or paragraphs from a 10K or really any document. But in this case, the use case that the bank was interested in was essentially, again, given a 10K large document, can we return this structured output where we're saying, for this company for a given year, here's all the text that's associated with legal and regulatory risk. So the specific paragraphs from that 10K that relate to that risk. Similarly, here's all the paragraphs that are related to a market risk, and here's all the paragraphs that are related to liquidity risk. And so there's a couple of reasons why you may want this. So a lot of flexible downstream applications. Again, in the interest rate swap use cases I'd mentioned, we've done this like targeted data viewer with confidence scores. But in this case, the team could use various downstream applications from extracting these risk factor paragraphs. First, I think anytime you take this large unstructured piece of text and turn it into a structured format, you can start seeing trends across various customers, various companies, various industries. So you can get to see, what is the trends in risk factors for a given industry over time, for a particular company over time, etc., and use that for dashboarding or analysis of any sort. You can also do risk alerts or monitoring where, if there's a particular risk that shows up for a particular company, or if there's now increase in the amount of legal risk for a company compared to the previous year, that's something that you may want to flag for investment decisions that you may be reconsidering. And then lastly, you could just use it for just accelerated document review as well, where, again, as I mentioned, these are really large documents, but let's say using the output, you can very quickly jump to the relevant part of the document. So you can say, show me the specific paragraph that talks about the legal risk, and then I can quickly jump to that part of the document and then review that very quickly. So many flexible downstream applications, but hopefully just to show you an example of how we can extract not just specific entities, but also large pieces of text like sentences or paragraphs as well. And again, in this case, labeling one single document, which is reading through a paragraph, saying figuring out what type of risk it is, takes 30 minutes. So labeling 50,000 paragraphs would take a really long time. And in this case, we were able to save hundreds of hours through this programmatic labeling approach. Again, get to a really high quality model. And then lastly, again, these applications are really adaptable based on changes in the data or business goals. And I just touched on a few use cases and case studies given the length of the webinar that we have. So we talked about some smart document, which is identifying meaningful information or insights from particular documents, or know your customers. But really, there's immense opportunity for machine learning in financial services, any type of text document that you're working with, whether that's in PDF or raw text or HTML, and whether you want to classify it or you want to extract, such that if you want to do news analytics, even conversational. So just a wide variety of use cases that we support in the platform that our customers have been able to utilize. And we've just sort of touched the surface in terms of the specific 10K extraction use cases that we've done. And with that, thank you so much. That's my email, so please feel free to reach out, and then we'll also be taking questions now. So.
Great. Well, thanks, Arthi. We have a lot of questions coming in. So I'll give you a few of them here. Folks, feel free to keep asking questions as we go along. If we are unable to get to your question live, we will follow up with you after the event with an answer. So Arthi, one of the questions is, does rich docs work over scanned images of documents?
Yes, so we handle both scanned as well as native PDFs, and we can convert them into our internal format.
Great. And can you talk a little bit more about your denoising process? Is it a human in the loop approach?
That's a great question. So the denoising process I briefly mentioned, where again, you write these labeling functions, which inject your subject matter expertise and let you label a large amount of data all at once. But then these labeling functions can be imprecise and they can conflict. And so how do you denoise them to get you to one label per training data point? So let's say, for a given document, or a given number, if 3 of my functions say it's an interest rate swap, 2 of them say it's not, how do I denoise it? You can use something like majority vote, which is a super naive way where, if most of the functions say it's an interest rate swap, I'll say it's an interest rate swap, but we do something more sophisticated on the back end. So even without any ground truth, actually, we're able to denoise these. And an intuition that may be helpful is we essentially look at how often these functions agree or disagree with each other and use that to automatically figure out the weighting for each of these labeling functions. And if you have some ground truth, we take that into account as well. So the denoising process is entirely done behind the hood. You just need to specify the functions. You can also say these are the particular functions you trust to give the model more signal, but the denoising is automatic.
Great, thanks. And kind of related to that, what can be the desirable training data size for programmatic labeling to be effective?
So really, you can work with a really, really large data set because you just need to write these labeling functions. So again, I think one of the parts that I didn't specifically mention, we do evaluate on ground truth in Snorkel Flow in general, just for best practices. So for that, we recommend having a very small validation or test set hand labeled in Snorkel Flow. We have hand annotation capabilities as well. But for the large training data, you don't need to be limited because you just write these functions and we can apply them to data sets that are arbitrarily large, which essentially you can have 100,000, 1 million, and you can just keep adding more documents and we'll just apply the functions and denoise them for you. So After a point, you may start seeing diminishing returns in terms of performance, but that's also something that we can help you figure out. So really not bounded by the data set size anymore because of this new approach.
Great. We have a handful of questions, Arthi, kind of related to Python notebooks and what's supported in Snorkel. And then kind of interrelated with that, just a little bit about the difference between Snorkel, the OSS, the open source, and then Snorkel Flow, what we're talking about today.
Yeah, so to quickly touch on the notebook part and then the major point. So in Snorkel Flow, each Snorkel Flow instance comes with a notebook interface, like a Jupyter notebook, and we have our own Python SDK that gives you a lot of flexibility on top of the GUI that's already in the platform. So you can write your own custom labeling functions, custom operators, custom models, really flexible as a development platform. In terms of open source versus the Snorkel Flow platform, everything I've shown you is the Snorkel Flow platform. The open source was, you can think of just research code that our founders put out way back when, and it's been in maintenance mode since 2017, but it's essentially a Python library to be able to write these functions and denoise them. But the entire capability that I talked about, like writing the labeling functions in the GUI, quickly iterating on that, training a model, then analyzing the model and doing that whole loop. And more importantly, for the 10K or PDF examples, having this rich doc format that preserves the formatting, that gives you additional information per attribute, this entire workflow around iterating on PDFs and the GUI-based interface is in Snorkel Flow, the platform. Great.
Yeah, I think Alex did a nice webinar for folks who are interested. It's on our YouTube channel about our open source DNA and a little bit about how Snorkel has progressed since that point.
John, quickly, if I may, we also have a blog post that you may want to check out that has a feature by feature comparison in terms of, well, there's way more in Snorkel Flow, and the Snorkel open source is just a Python library. You could check that out as well. It's called Advancing Snorkel Flow from Research to Production, I believe.
Great. We have a question in this rate swap use case, who's writing the labeling functions, Snorkel engineers or bank engineers?
So it's the domain experts that generally tell you, what makes something an interest rate swap. So FX traders will point out, like, this is what makes an interest rate swap. Different companies prefer different workflows. You could have subject matter experts write these labeling functions, but generally subject matter experts can also talk to the data scientists and then tell them what they're looking for in terms of the interest rate swap, and then the data scientist could encode it. So different workflows depending on the teams, but just a more efficient way to capture the domain expertise of the subject matter expert, and they are able to work on the platform if they choose to through the GUI.
Got a handful of really interesting questions in the Q&A, Arthi. Maybe pop open the Q&A and we can take a few from there. And again, folks, feel free to ask questions. There are quite a few coming in, so if we don't get to your question, we will follow up after. Arthi, I think you're on mute.
Sorry, I haven't figured out Zoom. It seems after 2 years in the pandemic. Why don't they write a structured contract? So I'm not sure if I understand the questions, but feel free to write your question again if I didn't answer it. But really, the 10Ks are documents that companies put out that are unstructured. They just don't follow a specific format. And these are publicly available documents that each company files. So we don't have a lot of control in terms of what format this document comes out in. It's just it's an unstructured large document that we have to parse through if we want to get the relevant information for that company. And if I didn't answer that, please feel free to answer in the chat or ask it again. Are large language models used for the ML models for the weak supervision? How are heuristics designed for the programmatic labeling? So you can use large language models in various ways. So we have an excellent blog post from one of our research team members around using zero-shot learning algorithms to come up with labeling functions. So you can use really large language models to come up with labeling functions. Like a few that I've written personally is, you can look at cosine similarities between embeddings, etc., to come up with labeling functions for a particular task. So you can pre-process your data in any way, either using Spacey, either using a BERT model, etc., to write these labeling functions. But really, the labeling functions, it can be as simple as something as a keyword-based labeling function. If it says wire transfer in the email, it's probably spam, all the way to more complex labeling functions using large language models, as I've mentioned. But the goal using this programmatic labeling approach is you're injecting your subject matter expertise in a much, much more efficient way rather than hand labeling. So that's how the labeling functions are designed, where you just think about like, why are you labeling something as a particular class and encode that? And that could be as simple as a keyword or as complex as an existing model, etc. And use that. And then of course, when we label data really quickly using these programmatic labeling approach, we do use large language models or even simpler models. It's provided in the platform to then train a model on that data, because we have really powerful machine learning models these days. Given a training data set, they may be able to generalize beyond the models. So once we label data, we also use models, powerful ones, to generalize beyond the functions. Great. How about generating 10Ks using generative methods? So really, I mean, I think the goal here is that given information that companies are putting out, how can we extract insights or turn that unstructured contract into structured data really, really quickly, and then see trends across customers, or just be able to make more informed decisions about investments. So I'm not sure what application would require generating a 10K from scratch, because really the goal here is for a lot of these applications to extract information that's out there in the void, but it's not very actionable. And so those are the use cases that we're primarily tackling. Do labeling functions work best if they're uncorrelated with each other? So we do handle correlations as well. I mean, I think generally you can just dump in your subject matter expertise, ideally if they're uncorrelated, but you don't really need to worry about if they are. We resolve conflicts and correlations automatically for you. Could I talk a little more about risk factors? Do you mind elaborating a little more on what you would like to know? I think that would be great. And okay.
We have another question in chat, kind of related to the ground truth, I believe. So without any labeled data, or what they're calling golden set, how do you measure recall and precision?
That's a great question. So for getting started with Snorkel Flow and getting the initial training data set, you don't need any ground truth. And we can resolve the various functions into one label per training data point. And there we can estimate the precision for you. Because again, the intuition is that we can look at, even if we don't know, what the ground truth is, if your functions overlap a certain amount, so there's some theoretical guarantees, or sorry, some criteria around the level of overlap, and you need at least 3 labeling functions. But just based on the set that they overlap in, we can look at how often they agree or disagree with each other and estimate the precision for you. In practice, a lot of customers do start with a small amount of ground truth just to iterate very, very quickly. And we can also auto-generate labeling functions at that point for you. In terms of calculating the final model performance, we do recommend evaluating on ground truth, but you can think of the final evaluation set is much smaller. Like let's say for a classification task, you may have 100 documents in your validation set compared to 100,000 or 1 million in your training set. So we do encourage and recommend for best practices to evaluate on ground truth such that you feel comfortable deploying your model.
We have a couple more questions. We'll take probably 1 or 2 more questions, and then we'll be wrapping up for the day, folks. So let's see.
Oh, I think we got a clarification on the risk factor, so I can touch on that. Okay, how do you define a risk factor? How would the model act when it comes across a completely new risk? So in this case, again, it depends on the company and how they wanted to formulate the task. In this case, this bank just wanted to sort of see the capabilities to say, can we extract text related to a particular risk factor? In this case, the way we define a risk factor is one of the sections in a 10K is a risk factor section. So a 10K does have a standard standard list of sections, but the document could be formatted in different ways. So it doesn't always say, section 1 risk factor. The formatting could be in various ways. But generally, one of the sections is a risk factor section where the company talks about what are the various risks that that company is facing, and they're obligated to disclose that. So the goal here was to say, can we take that risk factor section and do a more granular analysis as to the type of risk? So in this case, the team was interested in 3 different types. You can imagine you can extend that to many different types. In this case, I would also, we have not included this, but one of the categories we had is a other risk. So generally, this is not exhaustive. So we would generally have other as another category. And then the model, when it comes across a different type of risk or one that's not part of all three of these, it will categorize it as other. But one thing you could do is also monitor if the amount of other risk is going up over time to then see if you need to define a new class or anything of that sort. But hopefully that answers it.
Great. Well, we have one last question. It may be, hopefully we can take it. In the interest rate swap use case, the information is often repeated in the text a few times, duplication. They also at times give information about historical and/or terminated contracts. How does Snorkel Flow deal with that?
Yes, so the number is repeated multiple times, and you're correct to mention that you may want to resolve the amount that's extracted as well. I would really think of it as the step after this application that we've built. So really step one needs to be, let's first extract the interest rate swaps for a company. Then actually a downstream application we built on top of this, since you seem familiar with the domain at least, is we classified whether the swap is a fixed to floating or a floating to fixed type. So just two subcategories of interest rate swaps. You can also then post-process the data in various ways to do some of the things you mentioned. So you can see, if it's the same amount and it's mentioned in the same sentence or it's mentioned in the same table for the same year. You can pre-process the data to resolve duplicates. Or you can also just train further downstream models to do some of the tasks that you mentioned and resolve, which ones are closed versus open, etc. But really, this would be step one, which is let's first extract the swaps. Then you can do a lot of downstream post-processing or even downstream models to do the remaining tasks that you talked about.
Great. Well, thanks everyone for all the great questions today. We hope to see you again at an upcoming webinar event. And we can also go to snorkel.ai and register for our upcoming Future of Data-Centric AI conference, which will be in August.